Hi everyone, here are your notes for section 5.6. Now we're going to be getting into law of cosine. So if you guys remembered, we had case 1 and case 2 from 5.5 where we were using our law of sine. So if we had two angles in one side, so angle, angle, side, or angle, side, angle, or we had the ambiguous case of side, side, angle, we would use our law of sines. So now we're going to look into the other two cases, so case 3 and 4, which was side, angle, side, and side, 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 and how we would use the law of cosines there. So given the following triangle with sides A, B, and C, and angles of alpha, beta, and gamma, we can set up three equal ratios. These proportions are known as the law of cosines. The square of one side of the triangle equals the sum of the squares of the other two sides minus twice the product times the cosine of their included angle. And I'll spare you the fun. Let's go ahead and go through this and do the derivation together. So if we had our triangle, I'm just going to make a random triangle, label it A, I'll put C up here, and then B. So then this would be little c, little a, little d, or little d. Why did I have d there? B. I said B, didn't I? I think so. There we go. And then I'm going to drop an altitude down at the height. So your height of that triangle is going to split side C, or AB, into two parts. We don't know if they're equal or not. So I'm going to think about this as I'm going to make this x, this length from here, I'm going to make this point D just for reference right now. So from A to D is going to be x, which would make D to B be considered C minus x. Okay. So now I have two right triangles. If I look at the triangle to the right and use the Pythagorean theorem right here, this triangle, I have a squared is equal to, so that was your hypotenuse, right? One of your legs, which one of my legs is the height, so h squared, plus the other leg, which is c minus x squared, and I can expand that out. That's going to be c squared minus 2cx plus x squared, and then bring down my h squared. And I don't think I have anything I can combine there. No, I don't. So I'm just going to leave that as is. We're going to box that and remember that for later. Now I'm going to do the Pythagorean theorem on the triangle on the right, which I'm going to highlight in blue. There we go. So Pythagorean theorem there would get me b squared is equal to h squared plus x squared. Okay, so now in both of these expressions, I have my made up x values, right? So if I solve this equation right here, let's say for h, then I would get b squared minus x squared is equal to h squared. And then I could substitute this in place of my h squared up there. So now that first box turns into a squared is equal to b squared minus x squared plus c squared minus 2cx plus x squared. And then what's going to happen is my x squareds are going to cancel. So now I am left with a squared is equal to b squared plus c squared minus 2cx. Okay, so everything's looking good, except I still have an x in here. And x is just kind of my made up value that I just made it up so I had something to put there. So let's go ahead and jump over to that blue triangle and think about, well, what would x really be equal to? So I have an x, I have an h. Oh, nope, not an h. I don't want to use h. I have my b, right? And I have an adjacent and hypotenuse. So wouldn't that just be the same as the cosine of A is equivalent to x over b, which x would then be equal to b times the cosine of A, if I were to multiply that out. So now I can input that in place of x over on the right. So a squared is equal to b squared plus c squared minus 2c b cosine of A. And that is our law of cosines right there in a nutshell. And that can work for any variation. So it can work for, if I wanted to find side C, let's say, so if it was c squared that I was looking for, as long as this and this are the same, the stuff in the middle will just all kind of balance itself out as if you don't have them in the same order. So if I'm doing c squared, then I'm going to have to do a cosine of angle c. And then my other two sides that are left are going to be a and b. So a squared plus b squared minus 2. And then I'm just going to put ab because that's in alphabetical order, or could technically be ba, right? Or if I wanted to do it for b squared, then I would be doing the cosine of angle b, and then the rest just kind of falls in place. So I would write two unknowns, a squared and c squared, or not unknowns, I shouldn't be saying that, whatever the other two left out, minus 2ac, right? So it doesn't matter if your a and your c's flip-flop here and there, because the commutative property of addition and the commutative property of multiplication will keep it the same. Okay, so these are right here on your notes for you guys. So there's your a squared, your b squared, and your c squared. And then the right-hand side is just those equations solved for the cosine of the angle. So you could technically get from the left to the right without memorizing the right side, but we would use those if I had to find an actual angle. Okay, so techniques for solving. So if we were just given all sets of sides, so if we were doing side, 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 which I think is where we're headed to right now, find the angle opposite the longest side first, and then we're going to use the law of sines to find any missing angle, and then we're going to find the third angle by noting that they are all going to add up to 180 degrees, right? Okay, so let's go ahead and, oh, I guess we won't jump to it yet. And here's your techniques for solving a side angle side. So find the opposite side opposite the given angle, find the angle opposite the shorter of the two given sides, and then find your third angle. Okay, I just was getting so excited to actually physically do it. I wanted to jump the gun. All right, so here's our SSS. So given three sides of a triangle. I so had a better face. I don't know if Screencast-O-Matic freezes my faces or not. Okay, so here we go. Let's just start working. So we're given all three side lengths. So let's go ahead and solve for one of the unknown angles. I'm going to go for the measure of angle C first. Okay, so that means that I'm going to be doing a cosine of C is equal to, and then I'm going to do my a squared, so maybe I'll just write it out first, a squared plus b squared minus c squared all over 2ab is what you would get, right? So cosine of c is equal to 13 squared minus, I don't know, I put a 7 squared minus, oops, it should be plus. See, I was putting plus, minus my c, which is 19 squared, all over 2 times my a times my b, okay? Or if you don't want to have to worry about memorizing that, not that you're memorizing anything this year, you could just plug it into the equation on the left. Like I could have just done my c squared is equal to a squared plus b squared minus 2ab cosine c, plugged everything in, and then just solve that equation for cosine c, which would not be too challenging to do. 213 times. It's easier for me to memorize that, what I'm doing right now. Like I have that memorized, and then I could just solve that out for cosine c. So if it were me and I didn't have all this stuff sitting in front of me, I'd probably work through that, because I probably would be less likely to memorize the alternate form. That's up to you guys. Okay, so when you solve that out, we get 13 squared plus 7 squared minus 19 squared, and then we're dividing that by 2 times 13 times 7. So that's getting me a cosine of c is equal to, I don't know what them 0.7857 and some change. And I'm going to leave that there because I'm just going to do a second cosine, second answer on my calculator. So we're going to do a cosine inverse of that. And that gets me the measure of angle C to be approximately 141.79 degrees. Okay. So then, once we have that, I can now start solving for my other angles, right? So now I have C, so now I can do law of sines. So 19 over the sine of C, which is 141.79, is equal to, let's go for B, why not? So 7 over the sine of B. So when we solve that out, so 7 times the sine of 141.79, divide that by 19, tells me that my sine of B should be equal to 0.227885, some change. Do a second sine inverse on that. Tells me that the measure of angle B is equal to 13.17-ish degrees, which then I can easily find angle A, right, by subtracting those all from 180. So 180 minus 13.17 minus 141.79 gets me about 25 degrees. And now, depending on how you're rounding, you might be off a few decimals, but it'll get you there and close enough, right? Okay, there we have that one. Example number 2. So here we are given 2 sides and the included angle. So what do we want to do for first? We're given angle A, which means we're probably going to have to solve for side A. So we know that A squared is equal to B squared plus C squared minus 2BC cosine A. So let's plug it all in. So B squared is 5 squared plus my C squared is 3 squared minus 2 times 5 times 3 cosine, oh, my A, we know my A, cosine of 102 degrees. So cosine of 102 degrees. Okay. So 25 plus 9 is 34 minus 30 times the cosine of 102 degrees. So 34 minus 30 times the cosine of 102 degrees. That tells me that A squared is equal to 40.2373. And again, try to do as much work as you possibly can on your calculator. So I'm going to square root second answer. So A is equal to 6.343. Do I need to show you guys how to do the second answer? I guess I'm just assuming that you guys have that. I get my calculator up here. So you want your answers to try to be as exact as you possibly can. Make sure my mode is in degrees. I am. Okay. So if you are doing, what did I just do? I did 25 plus 9 minus 30 times the cosine of 102. And then I get that decimal. Then I'm going to do square root. And then second at the negative sign gets you your answer. So it's going to bring back your previous answer. If you did a second answer, then it's going to bring back 2 previous answers, which is kind of cool. So there you got your answer, the 6.34. Okay. All right, so let's bring this back. So now we have our side length of A, we have our side length of B, we have our side length of C. So now let's find another angle. So let's go with angle B. Why not? So 5 over the sine of B is equal to, now we just found A, which is 6.34, all over the sine of 102 degrees. So that's going to get me the sine of B is equal to, so 5 times 100 sine, 5 times the sine of 102, divided by 6.34, gets me 0.77141, some change. I'm going to do second sine, second answer, which tells me that the measure of angle B is about 50.48 degrees, which then tells me that the measure of angle C is going to be all of those added up and subtracted from 180. So 180 minus 50.48 minus the 102 gets us 27.52 degrees. Okay. And again, depending on which angle, like if I would have went for C first, I might end up with a different B, but they're going to be close enough. Like if you round it to the whole number, they're going to be the same. Because I think if you would have went for C first, you would have gotten 27.57 instead of 5.2. But again, it's 100th of a decimal, so we're okay. All right, moving on to application problems. So here we have 2 airplanes leaving an airport at the same time on different runways. One flies directly north at 420 miles per hour. The other airplane flies on a bearing of north 75 degrees east at 375 miles per hour. How far apart will the airplanes be after 2 hours? Okay, freeze. Ooh, that's a classic right there. All right, so what do we got happening? Here's my airport. Call this dot right here my airport. And then where are we going? We're going, so one flies directly 420, so 2 airplanes leave an airport at the same time. So we got an one flies directly north, and the other plane flies 375. Okay. So we've got 402 per hours. So we're going 2 hours. Okay, so here's one. So if we're going 420 miles in 2 hours, that means that this distance here is 840 miles. And then the other person is going to be going 750 miles in 2 hours. All right, 375 times 2. Okay, so we need to find the distance between them, right? How far apart will the airplanes be? So we know that the angle right here is going to be 75. Okay, so their bearing is, so east, I just realized you can't see me, right? So east, and then going north from there would give us this angle right here. Okay, so we're going to put that 75 in that angle there, which is across from our D. So we're going to do D. Oh, nope, we're not going to do D. We're going to solve for D. So D squared is equal to my other 2 angles. So 840 squared plus 750 squared minus 2 times 840 times 750 times the cosine of 75. And if you wanted to try to put it in one big shot on your calculator, let's go ahead and see if we can do that. I'm going to do a big square root, so square root. I'm going to do 840 squared plus 750 squared minus 2 times 840 times 750 times the cosine. Did I write sine or cosine of 75? Can't remember. So we get about 970.56. Yep, I have cosine. So D is approximately 970.56 miles apart. I love the applications of trig. It's just wonderful. And I love that my frozen face just came back. Okay. All right, so there is our law of sines, or cosines. So you still need to bring back the law of sines into the game when you're doing these to be able to solve all the way out. But we need to use the law of cosines if I'm given 2 sides and an angle, right? So for side, angle, side, or if we're given all sides, side, side, side. Okay, so now we're going to get to a specific formula. So we use the law of sines to find area of oblique triangles, right? So that 1/2 times your AB cosine of C, right, would work. But that only works when you're given an included angle. So what if you're not given any angles and you're just given side lengths and your triangle is not a right triangle, or it's very hard to find the height of it? We have what's called Heron's formula, which we use if I'm given just only sides. So this is kind of cool too. So here it is. So S is equal to 1/2 times, so S, let me back up. S is considered a partial perimeter. So if you add up all 3 of your sides, you get the whole perimeter. So if you then take half of it, it's going to be considered, so this is kind of, we call that the partial perimeter. All All right, and we can discuss it further if you want. If you really want to know the guts and the glory of where all this comes from, or if you just want to trust that it works, we can just say that we're going to trust that it works and it is what it is. Or we can get into it further if you want to. So that's how you would find your partial perimeter. So you take half of the perimeter. And then your formula then that you're going to use is right here. So to find the area of any triangle given the side lengths is the square root of s, which is your partial perimeter, times s minus a, times s minus b, times s minus c. So in example 4, find the area of the triangle if we're given a is 7 meters, b is 16 meters, c is 18 meters, round answers to the nearest square meter. So let's first find our s. So s is equal to 1/2, 7 plus 16 plus 18. So 1/2 of 41, which gets us 20.5. So now we're going to do area is equal to the square root of 20.5 times 20.5 minus 7 times 20.5 minus 16 times 20.5 minus 18, which simplifies out to 20.5 times 13.5 times 4.5 times 2.5. And then when you evaluate that out, you get about 55.798 meters squared. So it's saying round to the nearest square meter. So I'd say 56 meters squared. And that's pretty cool. So no matter what type of triangle you have, you can find the area given all 3 side lengths using Heron's formula. If you were given 2 side lengths and the included angle, then we would use our law of sines area formula. Okay, let's move down to example 5, which is going to conclude it. So it says a 120-foot tower is leaning. A 160-foot guy wire has been anchored 82 feet from the base of the... So guy wires are just wires that help stabilize things. Like, you remember seeing those floating men around? Well, there's wires that keep them from blowing all over the place. That's a guy wire. So a 160-foot guy wire has been anchored 82 feet from the base of the tower. How far from the vertical is the tower leaning? Okay, so let's get a picture of what's happening here. So we've got our guy wire. Okay, so we got here's my tower. I'm going to call this my tower. My tower is leaning 120 feet. Here's my guy wire, stretching at 160 feet. And it says that the guy wire is anchored 82 feet away from the tower. And we want to know how far from vertical is the tower leaning. So how far from vertical is the tower leaning? Okay, so what do we need to find here? So I'm going to call this my B. I'm going to call this my C. And I'm going to call this my A, just so we have reference to what we're talking about. So let's find this angle. Okay, so because if I can find that angle, then I'm going to be able to figure out how far it's leaning from the vertical, right? Because I want to know kind of if it's vertical, how far is it leaning? Okay, so let's go ahead and find angle B. So the cosine of B is equal to 120 squared plus 82 squared minus 160 squared all over 2 times 120 times 82. So that gets me the cosine of B is equal to 120 squared plus 82 squared minus 160 squared divided by 2 times 120 times 82. Make sure you put parentheses and all that jazz. That gets me about negative 0.227-ish. And then I'm going to do a second cosine, second answer. So the measure of angle B is about 103.15 degrees. Okay, so if this angle here is 103 degrees, let's say, vertically straight up would be at 90, wouldn't it? So if we're right here at 90, so how much more is it leaning past that 90 is what the question's asking. So to get our answer, we're going to do our 103.15 and subtract 90 from it, which tells me that it's leaning 13.15 degrees more past where it should be. So if it's supposed to be vertically up, right, it's leaning about 13 degrees past it standing straight up, if that makes sense. All right, that concludes your notes, guys.